Live from Utrecht, this is the fan Wirdum Sjorsnado.
Hello.
Hey Sjors.
I think we've got somebody else here.
We've got Joost Jager. Is that how Americans pronounce your name, Joost?
That's indeed how Americans pronounce my name. But the Dutch people say Joost Jager.
Joost Jager is in the building. Joost, please introduce yourself for our audience.
I describe myself as a Lightning developer. I've been working at Lightning Labs for a year or two and recently switched to Bottle Pay. And I've got also my own projects on the site, mostly contributing to the L&D repository.
Right, and I think one of the topics that you've sort of specialized yourself in or become an expert in is Lightning routing. Is that correct?
Yeah, that's correct. I did a lot of work on that in the past. Yeah.
Yeah, so Sjors, we did an episode on Lightning in the past.
We've done 2 episodes on Lightning in the past.
We've done some stuff on Lightning in the past, and it's all been very superficial. Is that the way to describe it?
I think so. So we explained Lightning at a high level, so you can listen to that episode. And then there was another episode where we talked about RBF replaced by fee and how it relates to some problems on Lightning. And that was very detailed, but also very bad.
Suffice to say, we're not the biggest Lightning experts in the world. So when it gets to sort of more in detail Lightning stuff, it gets pretty complicated for us, at least pretty fast. So I'm very happy to have a real Lightning expert here today. Joost, welcome.
Thanks for having me.
And we're hopefully going to, so we're going to get into Lightning routing more in more detail and explain what it is, what the challenges are, what the direction of development is there, and really get into it for this episode.
All right.
Sjors, are you ready?
I think I am.
All right, Joost, first of all, okay, let's start with a very basic question, just for maybe our new listeners, or just a very brief premise of what is Lightning and what is routing. What are we going to be talking about here in a very general sense?
The question, what is Lightning? All right.
Yeah, just in a few sentences.
Okay,
I'd
say it like this. Bitcoin is awesome, but it has several downsides. And Lightning is a technology built on top of Bitcoin to solve those. And then we're talking mainly about the fees that you pay to execute a transaction and the speed at which a transaction executes.
Yeah, it's a payment layer on top of Bitcoin that allows for instant transactions that are also cheaper because not all of the transactions end up in the blockchain, right? So then the next question would be, what is routing? What are we going to talk about? Why is this a problem or a challenge, or what is Lightning routing exactly?
Yeah, so with regular Bitcoin, you can pay to anyone who gives you an address without restrictions. It's a pretty direct process. Whereas with Lightning, your payment needs to travel through channels, and there's only a limited number of channels. So it isn't feasible for everyone to have a channel with all the other people on the globe.
And so maybe we can explain channels a little bit. So I could have a channel to Aaron, which basically allows me to send coins to Aaron, and Aaron could have a channel with you, and then he could send coins to you, but I can also send coins to you directly through Aaron without having to channel
indirectly,
to you. Yeah, indirectly, exactly. By basically sending it to Aaron first, and then he forwards it to you, and there's a bunch of ways that's made safe.
Yeah, well, that's indeed why you need routing, because there's a limited number of those channels. You need to find a path from yourself to the payment destination.
Yeah, the general concept is similar to the 6 degrees of separation idea, where you know everyone in the world through like a couple of people only in the end, even though there's billions of people in the world. The theory is that within just a few people who know each other, you actually sort of know everyone. So that's the concept that's being used here. The challenge is which channels in this case, which channels are you going to use to reach your endpoint? And somehow you need to figure it out. You need to figure out the routes to actually reach the person you want to pay, right?
Indeed, it's like a roadmap. So you know where you want to go. There's only a limited number of roads that you can take, and you'd like to find the best possible route to your destination based on, similar to with a car, either you want the fastest route or the shortest route. I like different options. And this is also at play in Lightning.
And this is why it's different from the rest of the internet, because on the internet, you just say, I want to go to this Google website, and all your computer has to do is send it to your router, and then your router sends it to your internet provider, and your internet provider sends it onwards, just like the postal mail. Like, you send it onwards, and every hop knows where to go next. They figured it out. But with Lightning, you have to decide in advance exactly where it's going and which route it's going to take.
Yeah, that's right. In Lightning, the sender decides what route is going to be taken exactly. And the reason for this is that Lightning has privacy properties that allow intermediate nodes, or that allow the sender to keep himself hidden from intermediate nodes. So the intermediate hops, they don't see where the payment is going. Sorry,
or where it came from.
Yeah,
right?
Well, also not where it came from, but they also don't know where it's going. And if every of those hops would find out the best path for themselves towards the destination, it wouldn't be hidden what the destination is.
And to make an analogy to the real postal mail, like, I could send Aaron a letter, and inside the envelope is another envelope that has Joost's address on it. And if you do that multiple steps, then, when Aaron opens it, he only knows it's going to Joost, and he might know it comes from me, but not where it's going ultimately.
Yeah,
this is how the Onion,
Onion
network works too.
Yeah, nor did I know that you were the first step. Like, there could have been 5 steps before.
Yeah, there could have been many, many envelopes outside of my envelope.
Right. Yeah, and like I said, this is also how Tor works. Okay, so that's...
And you also have to pay all the postage in advance.
That's a great analogy. Right. And also, the size of the envelope is always the same in Lightning, so you can't even see how many smaller envelopes are still inside.
So that's where it breaks down, because with real envelopes, you could put them on a scale.
That's where it breaks down indeed, yeah.
Well, actually, no, there's no way to fix that analogy.
Let's not try it in the analogy.
I was thinking about how to put fake envelopes inside of it, but you can't really without opening it.
You want to get into it, Sjors? Do you want to get into the envelope game, or?
Well, if you did the envelope game, then the way you would keep the weight the same is, I guess, by
replacing,
opening it and putting a new envelope in the innermost envelope without reading it. So, yeah.
Could you put pockets of helium in it to sort of counteract the weight balance, Sjors?
And then release the helium every time you ship it? I don't know.
But that's indeed what's happening in Lightning. Like, extra bytes are padded at the end of the packet to keep it of the same size all the time.
Right, so you have no idea where you are in the route.
Yeah, you don't know what hop you are.
Okay, so that's why the sender needs to figure out the whole route. That's why we're getting into the whole envelope thing, just to point out that the sender needs to figure out the whole route. So in order for the sender to do that, the sender needs the map of the network, right?
Yes.
Does the sender need the entire map?
It doesn't need the entire map. It needs enough routes to find its destination. Right. But in practice, you will receive the entire map.
Right now, nodes use the entire map to figure out. Okay,
at least the visible part of it, because there's also private channels, like say private roads. They are not on the map, but you need to get that information from a different source if you want to use those.
Yeah, and private channels can't be used for routing anyways. That's why they're private, I guess.
You can route over private channels, but you still need to know where they are.
Okay.
So you can have a routing node that has only private channels and is routing for users that know those.
So I guess the postal analogy here would be to say, dear postman, like when you ask your friend, like, what's your address? You say, well, this is where I live, but the postal service doesn't really know my street name. They only know the city I'm in. So here's what you need to tell the postman, like how to get from the city to my street or something like that. It's like a hidden instruction for the last pile. Or maybe the analogy is like use the mailbox on the left, not the mailbox on the right, or something like that. Maybe we should not do the analogy. In the Lightning Network, basically,
you need to be on the road outside of Hill Valley in 1955. Exactly. Oh, this is a Back to the Future analogy.
Exactly. Well,
anyways.
So in the actual Lightning Network, it's simpler, right? It's just that some of the channels are not known. So if you're receiving, say, on a mobile wallet, then what you do is when you make an invoice, you say, this is my node, and by the way, I am connected to this publicly visible node through this channel. So you have to use that at the end of your route, but the rest of the route is up to you.
Mm-hmm.
We're getting sidetracked. Let's just assume for convenience sake, I'm going to assume for convenience sake that we're using public channels. Mm-hmm. So in that case, your node needs to know the entire map of the network of all the public channels. So how does your node, I'm running in the Lightning node, how does my node get all of this public channels? How does my node know where all of the public channels are?
Yeah, so your node is connected to a few other nodes, and those few other nodes are also connected to a few other nodes, and through that, a whole network is created. And on that network, gossip is being passed around. So if there's one node who knows about a public channel, they gossip this to their neighbors, and those neighbors they keep
gossip. Just to be clear, is just sending messages, it's just sharing data.
Yeah, just sending messages indeed. Yeah. So it slowly propagates throughout the network because they're all passing on the new information that they received from their peers.
So every node basically shares with all of the nodes it connects to which channels it has, and then the next node does that as well, plus the information it got from the first node, and that's how all of the nodes end up with knowledge of all of the channels, and allows all nodes to construct a map of the entire network.
Yeah,
Is this correct?
Yeah, they share the information that they have with their peers, indeed. And in the end, everybody has the same copy, roughly the same copy of the network.
So what is the information that's being shared exactly? What information about these channels is being... Is it just the information that the channels exist, or is there more that's being shared?
Yeah, so most important are the endpoints of the channel, so between which nodes the channel lives.
Mm-hmm.
Another important one is the size of the channel, so you can use this to decide whether this channel is big enough to carry the payment that you want to send.
Mm-hmm.
So if you have a large payment, you can skip all the small channels. You don't need to evaluate those because they won't be able to carry it anyway.
Right.
There's also a pointer to the output on chain, so you can verify on the chain that this channel actually exists,
and the size of it as well, I guess.
Yeah, you can also observe the size from there.
Mm-hmm.
So this is very important to prevent spam on the network.
Yeah, the size in this context, of course, mean number of Satoshi or number of coins in the channel.
Yeah, the capacity of the channel. Yeah. So the maximum size that it can relay. So that's there. And there's also the forwarding policy for that channel. So if nodes advertise a channel that can be used for routing other payments,
mm-hmm.
those nodes, they charge a fee for that. And the fee is also advertised in this peer-to-peer network.
Right. So if my node is mapping the entire network, it knows which channels exist, or at least which public channels exist. It knows how many Satoshis or how many coins are in each channels. It knows how much it's going to cost me to route through that channel. But it does not, for example, know for each channel where the balance is, because the balance can be on either side of the channel, right?
Yeah.
So that's not communicated. That's not part of the map that my node has. Is that correct?
Mm-hmm. That's right. Yes.
So that sounds like that could be a challenge when you actually start routing, because it actually does matter how the balances are divided over the different channels, right?
Mm-hmm. That's right. If you start routing and you've picked your route, you've picked your channels, it could turn out that one of those channels doesn't have the balance on the right side, and then your payment fails.
Right. So how does my node calculate the best route? How does my node deal with something like that?
Mm-hmm. Yeah. You can look at this in different ways, but one way a node can implement this is that it assumes channels to be in balance always. So let's say if there's a channel that has one BTC, we will accept that it might be a little bit unbalanced, but not too much. So, for example, you could say a 1 BTC channel should at least be able to carry a payment of 0.2 BTC, for example, because it's not reasonable to expect from a 1 BTC channel that it's always able to carry 1 BTC.
Mm-hmm.
So if you assume that good routing nodes keep their channels balanced and that they let payments through those channels, and it doesn't happen, then you can take note of that as a node and avoid this channel the next time.
Right. Taking one small step back, so we're now getting into sort of pathfinding. I guess that's the technically correct term, right?
Yes.
And pathfinding, we already mentioned that this is something that a node itself figures out. The paying node essentially figures this out. This isn't like a protocol thing, right? This is something that individual nodes can do however they please, essentially. And is there a difference between different Lightning implementations, how they do this, or is this more or less synchronized as far as you know?
Oh, so the part that is synchronized is that it is optimized for cost. So there's cheap channels, there's expensive channels, and most of these of all of these implementations, they primarily look for the cheapest path to the destination.
Right.
But then between the node implementation, there's variation in other factors that play into this as well.
Right.
Yeah. So one of those factors.
So yeah, let's get into these factors. That's an interesting point. Okay, so we want to make a payment. We've mapped out the entire network. We know which channels exist. We know what kind of fees they will charge if they forward the payment. Now, there are obviously, I guess in most cases, there are going to be multiple potential paths.
Yeah, definitely.
In the same way that if you're traveling from one city to another, there are probably multiple roads you could potentially take.
Mm-hmm.
How do you decide on the actual route that you're going to take? How does a Lightning node decide this?
Yes. So besides the cost factor, there is the time lock factor. So in Lightning, it's quite technical, but if you send a payment in Lightning, there is a maximum time that this payment can take to complete. And this is a pretty long time. It could be like 5 days or even 2 weeks in some cases. So this is a parameter normally So it takes long because every hop on the network can potentially wait for a little while before forwarding. Yes.
Is that the reason?
So in the happy flow, it's near instant.
Mm-hmm.
But in the worst case, a node can sit on that payment and not do anything.
Right.
And then you have to wait until that ultimate time lock that you attach to a payment. So normally
until that expires, until you can sort of take the money back, right?
Yeah, so you can take the money back. And usually you don't see or hear anything of this, but only in a rare case that a node indeed does this, you see your money locked up for a long time. And if you've got two routes with identical cost, while one node only requires you to lock up the money for a maximum of 1 day and the other 7 days, we prefer the 1 day option.
Right, because in the worst case scenario, you'll get your money back faster.
Yes.
So you're making a calculation based on fees, based on time, and was there another factor?
Yeah, there's another factor, which is reliability. And this ties into the thing that we just talked about, where we keep track of the performance of nodes.
Mm-hmm.
And if certain channels don't perform well, we try to avoid them.
And by not performing well, you mean they previously either didn't have enough capacity, so they immediately said, hey, I'm sorry, I can't actually do this for you now, or they timed out.
Yeah, so there are multiple things that can go wrong. Like one of the most common things is that the balance is not sufficient in the channel, but it could also, for example, be that a node is offline. That can also happen. So there is balance, but the node is offline, so it still can't carry your payment. And there's also a variety of like more rare exceptions that we also use to update those reputation scores of nodes.
Right, and one of the problems with that reputation, as we talked about this before, so that's why I sound really smart, is that you don't necessarily know which node on the route screwed up, right?
Yeah, if a payment fails, you know that the payment fails, but in some cases, or maybe even in all cases, you don't know where it failed exactly. Is that right?
You do know where it fails, like a node sends you back an error message to the sender, and it contains its identity, a signature. So the node, it signs the error. So as a sender, you know where the error occurred, but it's still not completely clear whether this node is actually also at fault. So it's actually responsible for the error. So it could happen that node A sends a bad payment request to node B, and then node B replies with an error message. But it's not fair to penalize node B in that case because it's node A that actually sent the wrong request. So it's a little bit more complicated than
so
just
if you're neither A nor B, you're the one that made the payment, then you're not sure if it was A or B, or
you're not sure whether it's A or B. So what the sender does in this case is they penalize the pair of nodes. So they apply a penalty to the link between A and B.
Right.
So this can create guilt by association if you're an unlucky node next to a bad node.
Yeah, definitely. So you have to be very careful about which nodes you pair to because they are also influencing your own reputation.
Okay, yep. So I think you've now mentioned. You're basically attaching a score to nodes. Am I saying this right? So you've got a map of the network. You know all of the channels. You know how much funds each channel has. You know how much fees they charge. And now you're also applying a score to all nodes on the network based on their performance, based on your request to route through them. Is this right?
Yeah, well, not to nodes, but to node pairs. So we attach a score to node pairs. And
they're always two pairs, so it doesn't get calculated into individual nodes in the end.
Yeah, you're right. It does get so like at the basic level we assign penalties to pairs of nodes.
Yeah,
but some nodes have a lot of pairs, and to prevent us from trying out all the combinations of that node with all its pairs, we also extrapolate the performance of a specific pair to the performance of the node.
Right. Yeah. So nodes have a specific score.
Yeah.
Essentially.
Yes, you have a score.
So I think there was another heuristic you talked about when we prepared this, which is, I guess, never change a winning team would be a way to describe it. As in, if you're looking for a route to pay and you found one that's been used before and it worked really well, then you prefer that one rather than try something new.
Yeah. Now you're getting to the point. How is this reliability factored into the pathfinding?
Mm-hmm.
So what's the weight of a reliable or unreliable node? And the way this works, at least in L&D, is that previously successful routes, they are very much preferred until proven otherwise. So if a route is successful, it will keep that label until it's proven otherwise, whereas a failure slowly decays. Because if we would hold on to a failure forever, we would never give that node another chance. So there's like two different ways of dealing with a success versus a failure.
All right.
So if I'm understanding correctly, I think the way it essentially works is that your node has a map of the network, figures out what the cheapest route is, and by cheapest actually factors in these other things. So it factors in the fees itself, so that's sort of the most plain way of calculating the cost. But then it factors in the time locks, which you mentioned, and the reliability as sort of cost factors. And then based on all these three things, fees, time, and reliability, it figures out what sort of the real cheapest route is. Is that right?
Yeah, I would call that the best route. So best is a little bit qualified, but
Sure.
It means a combination of those things that you mentioned, yes.
Right. And just to reiterate this, nodes on the network, so my node makes this calculation, but Sjors' node could make a different calculation based on the past routing that Sjors has done and based on the past routing that I have done, right? It's an individual calculation for all nodes on the network.
It is an individual calculation, and it's based indeed on the experiences that a node has, but also on how you configure the node. So there's also room for the user to decide what they think is important, whether they value cost over reliability or the other way around. So
right.
I've talked about an analogy with restaurants, for example. So if you have been to a good restaurant, the question is, will you go to that every time again the rest of your life, or do you sometimes try a new restaurant? And between people, there's a difference in how they find this balance. So some people want to try something new all the time and have disappointments, and others, they never try something new. And this is a parameter that you can also set on your Lightning node.
Right. Interesting. So I've written about Lightning type of stuff in the past, including routing at some point, but I think it's been like probably 2 years since I wrote about this. Back then, the idea was, because there was a lot of criticism, I guess, or a little concern, or maybe concern trolling, whatever you want to call it, about how these solutions don't really scale, because it does mean that every node needs to keep track of the entire network. And at that point, the sort of answer to that concern was, for now it works. For now this is scalable enough. For now all nodes can keep track of this. And we'll now just keep track of how the network develops, because there's a lot of questions about that. Are we going to see a network with a few power players that do most of the routing, or are we going to see a very decentralized network? But for now, we're just going to see how it develops, and then we'll make our next decisions based on that. Is that still sort of the status, or are there other are there by now other ideas of how to evolve this over time, how to develop this over time?
Yeah, so as far as I know, that's still more or less the status. There just on the part of the mobile node, there has been some developments in those areas. Like a copy of the network is not that big for a modern time computer. It's very easy to keep track of what's there now.
For now, it's very doable.
Yeah, only for mobile nodes it's different. So you see that these mobile wallets they look for different solutions. So either they outsource the route finding completely to a server or partially, and in the case of partial outsourcing, they use trampoline nodes. So these are nodes on the network that have a copy of all the channels that exist, and you can delegate part of your pathfinding to that node.
So I think so. How this works, I think, but correct me if I'm wrong, is that your sort of your mobile wallet in this case would find a route to a special node, a trampoline node, which is, I guess, relatively close or something like that. I'm speculating here.
It doesn't matter where it is. It's just that you might, as a node, decide to only know the trampoline nodes. So as a mobile client, you instead of downloading,
you just know much fewer nodes, right?
Yeah. So you might, when you're listening to the gossip, you might tell your peers like, only send me gossip about trampoline nodes,
right?
And then that's a much smaller network. And then what you do is you when you're creating a route, you create a route to a trampoline node. And then you tell the trampoline node, essentially, that's sort of the inner envelope, like, go to this final destination. So you're compromising
the
a bit of...
The trampoline node figures it out from there.
Yeah, so you're compromising a bit on your privacy and on your ability to find the cheapest route. But the upshot is that, you don't have to know the map of the entire network. And there's some intermediate, solutions where you might use multiple trampoline nodes in your route. So the trampoline nodes also don't know everything about you. And there's other things you can do to improve your privacy even a little bit more, despite these trampoline nodes doing some of the work for you.
Right.
So there's interesting trade-offs there. I don't think that's been totally figured out, because I guess mobile clients, you just have to use them in the field and see how well they work.
Mm-hmm. Yeah, another challenge, I think, is or was that a lot of channels probably, just because of network topology or something, a lot of channels are probably mostly used in one direction. So sooner or later, they always end up depleted on one end and all of the funds on the other end, at which point they're no good for routing, or at least, not anymore in that direction. Is there any sort of solution? Is that a problem, first of all? And if so, is there a solution for that to sort of get a better balance or rebalancing strategies or ideas in that context?
Yeah, so the way I see this is that, as I mentioned earlier, a node should keep their channels available, like they should be available for routing. So if this happens, if a channel ends up depleted on one side, the fix should be to open a new channel, so that apparently there is traffic in that direction. There's money to be made in routing fees. So that pair of nodes should coordinate among themselves to open a fresh channel to keep that link lively.
You think it's better to open a new channel rather than rebalance or refund or whatever we want to call it, the existing channel?
Yeah, so we need to define what's rebalance and refund.
Mm-hmm.
It's like there's indeed different ways to do it. So you can open a fresh channel. That's the easiest way. You can also use a service like Loop, for example.
Mm-hmm.
So with Loop, and there's also other providers that do the same thing, you can push money out through a channel into an on-chain address. So you're basically loading money off Lightning into an on-chain address, and this changes your balance so that you can route more payments. But I'm always thinking, like, what does it cost in terms of chain fees? If you do Loop, there's two chain transactions involved. If you do open a channel and close a channel, it's also two chain transactions. So
Mm-hmm.
you have to be careful, like, is this really like the best option for me if I can simply open a fresh channel and that allows me to route more payments?
I guess one downside would be that because this reputation system you just described is based on channels, not on nodes. Like, if you open a fresh channel, that doesn't have the great reputation of the previous channel. No. But I guess that can be solved.
No, in LND, it's based on node pairs. So
it's
node
pairs,
so
not
it's
the channel name.
So it's the pair of node keys. So indeed, we thought about this, and this is indeed to get around the problem that if you open fresh channels, you would lose your reputation. So that's not the case.
Nice. Great. Okay, then everything is solved.
Nice. Done.
I don't know. Did we have any?
We are close.
No, is everything solved, Joost? I guess that's actually a good question.
Yeah,
is everything... Are we done? Is lighting done?
I think on the routing side, we have very few problems. Like at the moment, payments do succeed quite well. Only it's difficult to get like a definitive answer to that because everything is so private. You can't have like a master view showing you payment success rates across all of the network. If there are problems, it's mostly at the upper end of the amount range. So if you start to send larger payments, there are fewer channels that are available. And so if you see failed payments, they're usually there. If you want to send a 1 BTC payment, you need to find for channels that are able to carry that, and there may not be that many. But the solution for that is, in my opinion, just for the network to mature further, more of those bigger channels to be opened.
Along with the multipath solutions.
That's another way to get around that, to send it in multiple smaller shards.
So before Sjors declared Lightning done, I think the idea here is basically that it's a thing that channels get depleted, but the solution is simply that there is money to be made in offering non-depleted channels, and you think these incentives will work itself out and there will people willing to make money on offering these kinds of channels. So that's sort of the solution is incentives and economics.
Yes.
And you think this aligns well enough for it to actually work itself out.
Yes.
So that brought me to sort of a separate, related point, I guess. Let's say I have a Lightning node and I started it many years ago and I have a bunch of channels, but I'm super lazy. So the only thing I do is when I see some of the channels are closed, I just open another channel to somewhere. What's going to happen to my node? Is it going to be left alone in the universe because it's not balanced correctly? Because I'm not doing that, because that's work.
Yeah, if you're very lucky, you will get perfectly balanced traffic on your node, and you will keep getting free money forever.
I like that.
That sounds great.
But it's probably not going to be like that, because what's the chance that your traffic is exactly balanced? Probably not. So you will end up with depleted channels, and then you will need to open new ones to be able to keep routing, or other people need to open channels to you.
Right, and I guess so. What on a related note, like if too much money is on one side, you might think, well, I opened the channel, so all the money is on the other side, but whose problem is that? But of course, the other side might want access to that money, so they might have an incentive to close it.
Yes. So if from your node there's no economical destination to go through, this channel towards you will also be useless. Like suppose you charge a very high routing fee, like nobody will pick your outgoing channels on their routes, meaning your incoming channel is also not seeing any traffic. And if on that incoming channel the balance is fully on the side of the other node, they will basically have a useless channel with money locked up into it. So the reasonable thing to do then is to close it.
Yeah, and I guess this problem is bigger for mobile wallets, because mobile wallets tend to be at the edge of the network. So if I have a mobile wallet and I open a channel to Amazon and I'm buying a couple things on Amazon, then there's a whole bunch of money sitting on Amazon's side of that channel, but it can go the other direction unless I also get my salary, on the mobile phone through Lightning in the other direction. So I guess how would you solve that?
Yeah, that's a good question. Like it's not just mobile wallets, but like probably any like end user wallet that doesn't function as a routing node because the policies or the connections or the sizes of the channels, they are not right for being a routing node. If you have a channel, you open it and you're only spending very slowly and you accumulate more money on the other side. Yeah, how does it need to be compensated? So one idea could be that you will actually need to pay for this. So to pay for the channel to stay alive.
Yeah, you're renting the channel.
Yeah, and if you look at Lightning Labs pool service, for example, you're buying a channel, and the same thing is at play there because you get a guarantee that the channel stays open for a bit. I think this is something that can be it's a parameter in the system. But after that, the other party is free to close the channel again. So if you buy a channel, let's say you buy a 10 BTC channel, like extremely big channel, and nothing is happening on the channel, like there's a lot of money locked up there. So after the obligatory period that it needs to remain open, the other party will probably close it because there's so much money in there.
Yeah. Okay. Aaron, you had a question?
No, I was just wondering, I mean, are there any solutions for lazy people like Sjors to automate all of this stuff so he can actually be lazy and still make money?
Yeah, but I'm not just lazy, I'm also paranoid. So I don't want to run sort of like autopilot like software.
All right, is there a solution for lazy and paranoid people like Sjors so they can make money for free?
I'm okay with not making...
Impossible question.
I'm actually okay with not making money for free. What I would like the situation to be is that the next time I want to make a Lightning payment, I still have peers.
Ah, right. So you don't want to earn any money, but just want to keep healthy channels. That's what you want.
Yeah, pretty much. I want to have the ability to make payments when I feel like it and to receive payments when I feel like it. Yeah, but other than that, I don't care too much. But when if I don't look at the node for a year and I log into it again and it's disconnected, which by the way hasn't happened so far. Usually some of these channels are very old, so yeah, it's fine.
Yeah, well, it's a very good question how this is going to play out in the end, because indeed, if you have a channel and not all of the balances on your side, it is a cost to the other party. And if you don't look at it for 10 years, it doesn't work out for the channel to remain open for that long.
Yeah, unless so I guess the other side also doesn't care.
Yeah, if nobody cares, but in the end, I think there is always people who care because it's money, so they can also do something else with that. So I'd say that it is unavoidable over time to make some kind of a payments in that channel to keep it open, to pay for your checking account.
Right. I guess I would be okay with automation at the level of, this channel has a certain rent, so to speak. Mm-hmm. Yeah, just not too much magic.
Yeah, and it could be based then on the balance on the other side. So if you just open a fresh channel, all the balance is still on your side. The rent will be very low because your counterparty will have very few funds locked up into it at that point. Whereas if you are a merchant and you expect lots of incoming payments, you get a large channel from a routing node, then initially in that channel you will probably need to pay a higher rent because there's still so much value at the other side. And as you sell your goods and you're receiving money, that balance will shift to your side and the rent can go down.
Okay.
All right. Joost, is there anything else our listeners need to know about routing and pathfinding, or did we cover everything?
I think one thing that's interesting to be aware of, especially if you are a routing node, we already touched on that briefly, but I think it's still good to say that at least L&D as a sender tries to extrapolate the experiences that they have with some of your channels. So if you are a large routing node and you have a lot of channels, and a few of those channels are bad and all the other ones are good, then it's good to be aware that if senders use those bad channels, they may not also try all your good channels. So it's not that you just want to accept channels from anyone, because accepting a channel from a bad peer could lead to your node code being degraded and then your routing revenue going down, and then there's no more free money. Yeah,
so it's a bit that Sjors mentioned, that guild by association thing. So that is something to be aware of, especially if you're in it for the money and you want to make a profit by routing.
And quite strongly by association. So it's not just like, you had this guy on the podcast. No. It's like this guy tweeted about you. And now your reputation is soiled. Because somebody can make a connection.
A channel is still a bi-directional thing, right? You still need to agree to be part of the channel.
Yeah, but it's automatic. If I open a channel to you, then by default, you're just going to accept it within certain parameters.
By default, but this is something you can configure. You can create a channel acceptor plugin where you screen your potential peers. But it's all not out of the box, really, that's going to happen. But the routing nodes are not something that work out of the box. Well, they do work, but if you want to be a good routing node, you need to do more than that.
Yeah, so it sounds like it's a job, Sjors. I'm sorry.
Yeah, well, we'll see how it goes. Okay, I think that's all we got, right?
I think so.
So thank you for listening to the...
Joost, thanks for coming.
Yeah.
Sjors, do you feel like a Lightning expert now? Do you feel like a routing expert?
A little bit more.
A little bit more, me too.
So thank you for listening to the Wirdum Sjorsnado.
There you go.